not a problem on our side. We'd really appreciate that. Okay, so today, whoa, that's very bright after those dark slides. I'm sorry about that. Didn't mean to blow everybody's eyes out. The agenda today, we're going to talk about the Adobe Target profile, then we're going to talk about BigQuery, and then there's a Q&A. And I realized that I put the presenters in the wrong order, so I'm just going to do Brian first and then like Luca. Brian is our head of optimization technology. He's going to be our first presenter today. He's got almost 2 decades of experience, and I hope he'll tell you about some of that. He has founded optimization practices in even companies, and he now works with us. We're very lucky to have him. Our second presenter is Luca, and Luca is an AdSource senior data scientist, and both of these guys are nice and humble. He uses machine learning to help clients build valuable insights that predict trends in user behavior. Both of these people are truly subject matter experts in their field. I can't wait for you to learn from them. So with that in mind, what I'm going to do now is I'm going to turn over the presenting to Brian so that he can walk you through the things that he wants to walk you through. Brian, you are now the presenter. Feel free to take over.
Okay, cool. Thank you so much. And perfect. And thank you all for joining today. Very, very excited to be here and to geek out over this subject, which is kind of like near and dear to my heart. So just a little bit of background. So I've been using Adobe Target since 2006. I came from Informatica, which is now the Adobe Target product. I was the lead Adobe Target SE for a number of years before starting a consultancy at Analytics Mystified. And then I started this software tool called Miaproba as a little side hustle, and that grew year over year. And I had the good fortune to have Miaproba get acquired by AdSwerve, head of the optimization technology, where I'm helping companies scale their optimization programs and do very cool things like what Luke and I are going to talk to you about today. So I'll jump into it. And like Sandra said, please hit us up with questions. We should have time to address them and go deep technically if you'd like us to, and to jump into specific examples. So what I'm talking about is the Adobe Target profile as a prelude to the really sexy stuff that Luca's going to get into with BigQuery. So the profile in Adobe Target is the cornerstone that kind of makes this capability exist. So the Adobe Target profile is the cornerstone by which everything in the Adobe Target platform is mapped to. And it's an open profile that allows organizations to do different things with it. So I'm going to walk through kind of like what that means and what it looks like. And so in this profile, this kind of concept here, you have different variables based off behavior, environmental variables, referrer variables, temporal variables. But what we're talking about is data that might not exist and might not be exposed to Adobe Target to use for audience targeting and some of the automation work that takes place within automated personalization and auto target. So I'm kind of get into the weeds a little bit just so you can understand kind of like the framework that's in place. I'm going to go to kind of real examples. So the profile is a mechanism to allow organizations to target as part of the audiences within Adobe Target, but it's also used for some of the modeling that takes place within automated personalization and auto target. But let me get into kind of like exactly what this means and how it works. So I'm going to jump around to a couple different scenarios where Adobe Target is in place. So you can kind of get a sense of what's going on. So I've got Adobe Target in place. This utility, you're going to see me use this utility quite a bit. It's a Chrome extension that we built free for the Adobe Target community. Feel free to kind of play around and download it if you use Adobe Target. And so Adobe Target's on this page. It's on this page client side, and you can kind of see that when I refresh the page, it is there. And the concepts that I'm talking about here, 100 applicable for server-side Adobe Target, which I'm a big fan of. And so Adobe Target, as you see here in the Chrome extension and in the network request, is passing data, but it has an ID. It has a visitor ID that's being set. This visitor ID is with a first-party cookie that's being set on your site. So all of you on the phone that are using Adobe Target, you have this cookie called the inbox cookie, and this is a visitor ID where the different attributes are mapped to the particular visitor. So here on the homepage of Miaproba, I'm in a lot of tests. I'm a visitor of this test. I'm a visitor of that test. I'm also a visitor in tests at different locations. And that's all mapped to the visitor ID that's within here. And so this visitor ID is automatically there just by simply putting Adobe Target on the website. The visitor ID has a 90-day rolling profile. So within the Adobe Target interface, you're able to kind of define and adjust the length of the profile within here. Underneath the implementation, you can see your profile length. So it's defaults to 14 days. If you want to send a ticket to client care, they'll immediately extend that to 90 days, which means that these attributes, as visitors get assigned activities or do certain behaviors, that the values exist in Adobe's ecosystem for 90 days. If a visitor comes back 2 weeks later, it pushes the window back 90 days behind the scenes. All of the advanced organizations that are using Adobe Target lean heavily on this profile. It is powerful, allows you to do lots of different things based off of behaviors, based off of data that you want to pass to Adobe Target. And I'm going to walk through the different ways that you can kind of put it in place. So using Adobe Target's ID, so going back to the visitor ID that's here, so Adobe Target gives you this ID to use, you can set profile attributes in a few different ways. You can pass it client side, just like how you do with the analytics, you can pass the data. And I was kind of crawling around on the internet and looking at different sites and seeing different examples of this data being passed. In here, this site, I was taking a look, and you can see here that there's profile parameters being passed client side. I was able to detect Miaproba and different things that they were passing as parameter value pairs. This is a very common way in the Adobe Target community to just give data to Adobe Target. And once this data is passed to Adobe Target, it's then associated with my ID. So here's my visitor ID on this domain. And so all of these different profile attributes you can see are within here. So first way is client side, just passing it as parameter value pairs. Very, very helpful. The other way to do it is within the Adobe Target UI. I actually set one up this morning. This is more of an advanced feature. We have utilities to make this a little bit easier. But when Adobe Target gets a request, there's data that's passed along with it. And so I set a profile attribute. So when someone comes to the website and the URL contains trial, it creates a profile attribute that looks like this: trial start equal to true. And so nothing was done with the implementation to make that profile attribute possible. It was just simply done in the UI. And you can see here that my visitor ID, there it is, user trial start equals true. And so that's just kind of a one way where an organization can take something like this and the URL, create a profile attribute, and then they can go and target people based off of that particular behavior within there. So those are the two kind of like common ways where it's done within the Adobe Target UI. To show you a little bit kind of behind the scenes, what happens, and as an example of just how important the profile attribute is to the Adobe Target ecosystem, the profile gets updated before any activity evaluation. So I'm here, I'm on this website, I'm participating in all of these activities that are taking place here. Okay. Before Adobe Target responds back to the page with what activity you are being assigned and what experience you're being assigned, it updates the repository. So the server call, whether client side or server side takes place, the first thing it hits is the visitor profile repository. So it either creates a brand new profile if you're a brand new visitor, or it updates the profile based off of additional contextual information. And so all of the profiles are then processed and evaluated. And at that point, the assignment to activities and experience takes place. It's an important component. And something that kind of ties into this BigQuery thing, so you can know about visitors being properly assigned on that first impression. That's where the visitor attributes kind of come into play within there. And just so you can kind of see behind the scenes, like what's going on. We talk about like profiles and that sort of thing. I think it helps to kind of see what it means in the Adobe ecosystem. So Adobe's got a visitor edge network, right? They've got different sets of servers around the world for performance reasons and for redundancy and things like that. And so I'm based in Chicago. So my visitor profile lives in this edge network. I'm closer to Virginia, whereas Luca, he's on the West Coast. His Adobe target visitor profile is likely in Oregon within here. And so in there, as you can see, all the different, there's big databases with all the different user IDs that exist within there, and then any of the profile attributes across the different columns within there. And so there's the profile, and all of the metadata that's associated with it is commonly referred to as profile attributes. Now, the powerful part of the Adobe target profile. So a lot of tools have ways to kind of pass data to it for targeting and personalization. Where Adobe did, it took it to another level by shifting its optimization platform to a first-party platform. And so organizations can pass their definition of a visitor ID. There's absolutely no need to just rely on this. You could if you don't have a first-party ID that's available. You can see that I'm leveraging it here within Miaprova, and lots of other organizations do it. Yesterday, I was ordering lunch, and I noticed the lunch provider was doing this. So I was ordering food from Panera. I was like, oh, look at these guys. Look at them. They're passing their first-party ID over to Adobe Target, which is pretty cool. And so what this enables is so many powerful things. First and foremost, it aligns your optimization program to the definition your company has for the visitor ID. It enables cross-device test coordination. So if I'm on miaprova.com, I have a test, or I'm on Panera, and I'm in a test on one device, authenticating on another device immediately puts me back in whatever activities I was assigned as part of that test evaluation. This also enables the ability to use any data that's mapped to your ID, and we'll show you kind of more of that in just a few minutes here. But it also kind of allows for the organization to have cookieless personalization. So if I go and clear my cookies or go on a brand new device, as soon as I authenticate again, Adobe Target immediately brings all of that information back on that first impression, which kind of goes back to the slide that I showed you with the first thing with being the visitor repository within there. And so this is one of the easiest things to get in place and one of the most powerful things. So for those of you that are on the webinar, if you're using Adobe Target and you have a visitor ID, I can't stress enough how powerful it is to simply get it in. It's just a parameter value pair that you pass to Adobe Target, and you're off to the races to be able to kind of open all of this type of functionality that exists within there. And so I want to kind of show you just quickly how we can use data for first-party attributes in just a few slides, and then pass it over to Luca. So just like I showed you with the parameter value pairs here, on this website within here, where you're passing data client side to Adobe Target, you can absolutely do that. Here you can see parameter language en site USA. Very, very helpful. Server-side scripts, which I showed as well. The other mechanism to do it is via Adobe's offline APIs. And so I was looking at some of the different profile data that was associated with me, Brian. So here is my ID, unique ID, the first party ID that Panera has for me. This is the Adobe ID, and then this is the Experience Cloud ID, which stitches a lot of the Adobe tools together. And so Adobe Target profile attributes can be mapped to any one of these IDs and used in the Adobe Target platform. And so I was taking a look at some of the different attributes that were there, and yeah, I can see that they're doing things like category affinity, which is a lovely, cool, fun way to use the Adobe Target attributes. But I can also see that they have some offline data. Things like, okay, I'm a salad lover, which is pretty cool. You wouldn't know it by looking at me, but I do like their salads. I do not subscribe to their coffee thing. So they're bringing this offline information to Adobe Target clearly, and I don't have a relationship with Panera. I'm not exposing anything, but I could just tell this just based off of the data that's being communicated to Adobe Target. And so this allows the organization to use all of this rich data to do some pretty cool targeting. Like, look at this. Enjoy a free salad, a free half-off sandwich or salad and pictures of salad. So it is powerful for personalization and for targeting. And so, like I said, if you have a first-party ID, you should definitely pass it. And regarding the offline APIs, two things I want to highlight here, and then I'm going to hand it over. So Miaprova, we want to kind of enable this capability for organizations. And so we have a free utility that's available for people to use. Adobe's got wonderful documentation. I have links to it on the bottom here where you can construct your own platform to get this offline data over to Adobe Target. But give this one, if you want to kick the tires. So we provide two templates, you based off of your visitor ID or Adobe Target's ID. So you would download that template, then fill it with data and simply upload it here, and then it'll show up within the Adobe Target platform. I did this a little bit earlier today just to get some additional data within here, and so you can see some of the different things that have been uploaded. All of that's been uploaded because I told the template, hey, for this visitor ID, throw in a bunch of parameter value pairs, and that made it available within Adobe Target, and then I can use it within the audience creation within here. I can create audiences where you can see all of the Adobe Target data within here, all of the different attributes that have been used and been passed to it. So that's a free utility. Go out there and play with it. But what I want to highlight here is something that we wanted to do to automate BigQuery data into Adobe Target. So this is the Adobe Target platform, optimization management, where organizations can manage their optimization program, get visibility into how tests are doing. They've got the program overview, real-time reports. They can see the impact across the organization. There's a lot to this particular platform that exists. And so we had a webinar a few weeks back regarding GA4 for T, which is the integration with GA4 and Adobe Target to automate the reporting within GA4 and to create audiences and that sort of thing. And so today, what we're highlighting is the integration with BigQuery. So here we have the connection to the Adobe ecosystem that exists within here, some of our other integrations that exist. But specifically, I want to get into the BigQuery integration. And so within BigQuery, there's lots of stuff within here. I'll let Luca talk about that. But at a high level, you can create audiences based off of user IDs, the same user IDs that are communicated to Adobe Target, whether it's Adobe's ID, whether it's your first party ID within that that's being passed to Target. And so as these audiences are being created within our platform, within BigQuery, you can select to have Mia Prova automatically send them over to Adobe Target. So they're available for you to use within audience creation within here. It's also used for Adobe Target's automated personalization, for random forest content decisioning, that sort of thing. Let's see here. And so the last thing as part of this is you can have Mia Prova do it once, or you can have Mia Prova do it every day, where we update the profiles real time. And so once a day, they'll be sent over to Adobe Target based off of any of the kind of the audience growing or shrinking on the BigQuery side. So it looks like cool. I saw a note about the Adobe Target webinar in GA4. So any questions on this before I hand it over to Luca in terms of the Adobe Target profile, what it means, using the visitor ID and associating data with it? Say that. Okay, I'll hand it over to Luca.
We actually did have one question, Brian, how that differs from you using ECID with AEP.
Ooh, great question. So no, so this that actually gives you even more opportunities. And so the question is about like the ECID, which is the Experience Cloud Visitor ID, and the Adobe Experience Platform. So the Adobe Experience Platform is the platform that includes like CJA, AJO, the real-time CDP, and Target's got direct hooks in there. The ECID, I love it. You pass data to that. That data can also be part of a profile attribute. Same thing as customer attributes within Adobe Analytics. And the ECID can also be a primary key to have data in there. It's still an Adobe ID, which is great, but I would recommend to align your optimization program on your ID, which can be joined obviously with the ECID. Great question. Thank you.
Thank you. And we got to thank you in the Q&A. Luca, it's all.
Awesome, thank you. Hopefully you can hear me. Yes, we'll be discussing BigQuery. So we had Brian kind of make a little bit of an intro, show how we can connect BigQuery to Mia Prova and to Adobe Target. But I'll start diving into what it is, how it works, and then we'll look at a few opportunities and how you can take advantage of BigQuery to really enhance, create those audiences, make predictions, etc. So BigQuery today is described as a fully managed data warehouse, which means that in comparison to other data warehouses, you really don't have to worry about what's powering it. So you don't have to worry about how many servers you've purchased to store your data. You don't have to worry about being able to manage the load of your queries, even if it's querying petabytes of data. BigQuery will be able to deploy appropriate amount of slots to handle your queries. So it's still fully managed. Again, you really don't have to worry about infrastructure. It's in Google Cloud, so that's where it lives. It's AI ready. We'll check a few examples, especially recently with the development of LLMs. There are a few pretty cool things within BigQuery that allows you to write queries, even if you don't really know SQL. But overall, just multi-engine, multi-format, and now multi-cloud as well. So by multi-format, they mean that it's for structured and unstructured, semi-structured data as well. So you can have JSONs in there. For unstructured data, you can actually have object tables that connect from BigQuery to something like a cloud storage, and it can run multi-cloud today. So if you have data in AWS or Azure, you can connect all of that together and run it with BigQuery as well. If you have used BigQuery in the past, one thing that I would note here, it's developing quickly. There are new features every year. Recently at a Cloud Next conference, they said that just in the last 9 months, in the previous 9 months, there were about 130 new features added to BigQuery, which was a pretty insane number. And a lot of these features are not small, they're pretty large updates. So if we look at something like 2016, it was just a data warehouse for super fast SQL libraries. So they didn't even use standard SQL. You could only append to the tables. So you weren't able to update, delete rows and running on GCP. And then later they added its petabyte, it's low cost, data warehouse for analytics. And today they're even more than data warehouse, calling it a unified data platform. So it's been pretty cool to see the development of BigQuery through the years. For this purpose today, most importantly, it's a data warehouse in the cloud that you can pretty seamlessly connect with Mia Prova, which means that you can use it with Adobe Target. So quick overview, mostly what I just mentioned, data warehouse, but actually also a unified data platform. What's being called today, it's part of Google Cloud Platform. GCP would be that abbreviation that you see floating around. So if you have a GCP project already, it's just another service within the list of capabilities that GCP has. So you'll have compute options like Compute Engine, App Engine, Cloud Run, Cloud Functions. You have a lot of different databases, storage systems, and BigQuery is just one of the services within Google Cloud Platform. And by my subjective opinion, it's the best service and what separates it from AWS or Azure. An interesting thing about BigQuery is that it separates storage and compute, and that's one of the things that allows it really to be fully managed. Because when we're storing data, it's only stored on, we pay and we store. We don't have to reserve, and it's based on the current need. We don't have to add storage because we may fill it up later. It's very scalable. The more data you add, the more you'll be paying for that data, and you don't have to worry about that separation of storage impacting your compute. So if you have a lot of data and you're running small queries, whenever you're running queries, that scalable compute will will start with a fewer number of slots, and when you're running big queries and large queries, it'll deploy larger number of slots. So separation of the two is very useful, especially when storage may be massive and your queries may be smaller, or the other way around. And of course, you're not using compute all the time. You may just be using running queries at certain times of day. So that's when you're deploying that important compute machinery. And then for storage, you're just using disks, or Google's doing that in the background for you. One thing to note here, it's an online analytical processing database versus the transactional processing. This means that it's very good for any analytical queries. So if you're looking at the average across millions of rows, this will perform really well. It will give you a response within a couple seconds. It's not a transactional processing database, so it's not optimized towards scanning individual rows, or in some cases individual root users, and returning that data back. So there may be a little bit of a lag. You always get at least, let's say, half a second before you get a response from BigQuery. But again, it's geared towards analytical workloads, and as data warehouses versus more traditional databases are. So one thing to note when you're thinking about how to use it, BigQuery is meant to be used for analytical processing. And another thing added here, the columnar storage, which goes along with the analytical processing. So in traditional databases, the way the data is stored in the backend, it's row by row, index by index data is close together, versus in BigQuery, everything in a column is close together. So as we're scanning data, as we are writing queries, that's something very important to note, because if we have a where clause that limits us to a single row, a single user, let's say, it'll still scan every single user and all the rows within that table to give us information about that user. But if we're only interested in, let's say, time on site and something like a web analytics table, even if we want to know that information for every single user, it'll just scan that one single column and we'll be able to ignore the rest. So you can think of it as very vertical versus horizontal in the way it accesses that data. It also has some optimization when it comes to scanning only certain rows with partitioning and clustering. So very quick overview, it's analytical database, data warehouse, turning into a unified data platform with everything else that it offers, and very powerful and scalable. Like I said, you can run a petabyte query on it. I'll quickly touch billing because it tends to be an important part, and we'll see as we're running those queries how much they're costing. So if you want to start using BigQuery today, there's a BigQuery sandbox. You can start using it free of charge. You don't even have to associate it with a credit card. You will receive, I believe, 1 terabyte of scanning for your querying and analysis, and you'll also receive 10 gigabytes of free storage. So as long as you're under those limits, you can take advantage of BigQuery Sandbox and run your data warehouse for free. If you start streaming data into BigQuery, for example, Google Analytics 4 can stream data and all the events happening on your website directly to BigQuery. There's a small cost associated with that of 5 cents per gigabyte. And then as you're running queries, the most common way to pay for those queries is pay as you go. So you'll just pay $6 for every terabyte of data query. And the other option is you can reserve those slots in the background, and that will cost about 4 cents per slot per hour. And usually this will go into chunks of 100. So you would be paying $4 per slot, per 100 slots for the hour. And you can run as many queries as you want during that period, but you may be limited with the processing power to those 100 slots. So within BigQuery, this is a quick overview of the UI. It lives within a Google Cloud project, and then within the Cloud project, we have datasets, and within those datasets, we have tables. Along with the tables, you will also notice we have views, materialized views, routines, function, object tables that connect to Google Cloud Storage, for example, and we can use standard SQL to query that data, along with a few additions to it to allow us to work with, for example, semi-structured data, so we can have some nested fields like in a JSON. It allows us to also run BigQuery machine learning, which we'll look into in the next few slides. But overall, if you have experience with something like a more standard database, MySQL, Postgres, Microsoft SQL Server, knowledge of standard SQL translates really well, and you'll be able to start running with queries in BigQuery very quickly. And then a few additions that there are, like accessing semi-structured data or arrays, nested fields, takes a little bit of learning, but it's pretty easy and quick. And query execution. So as I mentioned, fully managed also means that queries are run for you. Or queries are run for you in the background. You don't have to worry about deploying compute servers to do that for you. So if we look in a publicly available data set, and in this case, we'll look at the Natality data set that's available in BigQuery. You can see here it's 22 gigabytes big, 137 million rows. And if we run a quick query on it, so for each year that we have data, this is basically a data of 137 million births within the United States, and we know what day it happened, what was the age of mother, for example, and the gender of the newborn, and their weight in pounds. So one thing that we'll do here is we'll do average weight in pounds for each year and order it by the year ascending. So again, this is something that you can do just straight out of that BigQuery sandbox. Public data sets are stored publicly, so you don't have to worry about storage. One thing to note is I was writing this query, it's accessing year and weight pounds. So even though I believe we saw it was about 20 gigabytes big, when we ran the query, it only accessed 2 columns, and we scanned 2 gigabytes of data, and this is how we then pay for it. And if we look at the execution details, you'll see that there's a few steps that happen, and it takes care of some of the parallelization. So it runs all this in parallel in the background. You can see it only took a second to go over 130 million rows. It consumed 29 seconds of slot time. So there were multiple slots, multiple machines in parallel running this for us. So you can see 137 million rows went in, and we have 40 years of data. So 40 rows at the end because we're grouping by the year, and 5,520 fields were generated after the first step. So if we divide that by 40 rows, we can see about 138 slots or machines ran this in parallel for us in the background. So just very quickly to give you an idea of what all is possible with BigQuery, how quickly it runs things. And now let's dive a little bit into BigQuery machine learning. So as Brian was mentioning, Google Analytics exports data into BigQuery. It does that in a couple tables. And if we focus our attention right here, you'll see we have events table, which has every single event that happened here on the previous day for all the users with a lot of dimensions and metrics associated. A very similar export is available for Adobe Analytics as well. And then the next table that we have is a user export table, or in my case here, I have a pseudonymous user, which is based on that first-party cookie. So it's not connected to our user ID yet, unless we do so. But even for all the just first-party cookie identified users, basically everybody that visits the website, we get user information. And along with that user information, we also got the audiences in our schema. So if in Google Analytics 4, we set up audiences, you can see those are coming through. In this case, we just have all of them in an audience called all user. There's some sorting happening, and we can take advantage of that. But outside of just taking advantage of the export that Google Analytics offers us, we can also take advantage of BQML and start predicting our own audiences or importing other data sources into BigQuery, joining them with Google Analytics and get that first-party cookie, and then sending that to MiaProba, or better yet, MiaProba can actually read from it and then using it in Adobe Target. So just like you saw that in that Panera example, some data was not available, like salad lover. You could have that information in your CRM and then just start joining it and sending that back with the first-party cookie to MiaProba. A couple of examples that I'll show here, though, are with BigQuery machine learning. You can use BigQuery machine learning to train models on the data that's within BigQuery, and then also to make predictions of new users using tables, data that you have in BigQuery to then create, in our case, new audiences. You can also tune, you can evaluate, there's hyperparameter tuning available within BigQuery. So you can do a lot of that data science work within BigQuery using SQL itself. An example that I'll have here is from AdSwerve website. With all the events that we have, we want to predict what users are most likely to sign up for our newsletter. So in preparation for this webinar, I created a pretty straightforward set of queries. So one, it looks at who converted. So we got user pseudo ID, and that's that first party cookie that Google Analytics uses that can then be leveraged for targeting purposes as well. So I'll look at who converted. So give me only user pseudo IDs where event name equals newsletter sign up complete. I'm interested in what their first interaction is like. So what's their operating system, browser, continent? How did they land on our site? What are the source medium that gets that user to our website? So first interaction here, we'll try to predict if someone will convert. I also added additional data here. What's their behavior like within the first week? So are they reading our blog? Are they looking at partners' website, webinars, landing page? How many times they've read our blog? How many events they've triggered? So a lot of information about those initial interactions of user with our website. And based on that, we can then try to predict how likely someone is to convert. So at the end of this, we end up with a train table. Our train table looks something like this. So we got a bunch of rows. For each row, we'll see continent, we got operating system, browser, medium, then landing page, number of times they saw blog in the first week, number of events they triggered in the first week, and then we have a label, the most important thing at the end. So did they sign up for our newsletter or no? A very small amount of users to our website actually signs up to the newsletter, so you can see the labels mostly showing here as false. BigQuery also does some sort of ordering, sorting of the tables when I just go into the preview. But you can see here we got continent, operating system, browser, medium, everything ready to start feeding our training model, start training our model. How to train the model now? It's actually within BigQuery pretty simple. So I'll copy the query here so you can see it. But we will create or replace a model if it already exists. It's called our newsletter sign up model. You can pick from about 10 different algorithms. So you could do neural networks. We got logistic regression here as an example. There's random forest, boosted trees. So there's quite a lot of options. There's a lot more parameters that you can include in this training. And then we'll say, okay, create a model called newsletter sign up model using a logistic regression, and then read from that training table that we just created. So if I run this, it usually takes a few minutes depending on the size of the data. And like I said, in the backend, BigQuery is really smart to run this in parallel. So we could see that in execution graph towards the end as well. But what it will produce is our model. So our model, it'll let us know how it trained. It'll give us a little bit of, it's still training, so evaluation data is not available yet. But then it will also let us know what the schema looks like. And this is schema that then we can start using to make predictions. So now I also created a table of users that visited our website in the past week. And for those users, I can start predicting how likely they are to convert. So if I have a table of users, I can just query our model. And you'll see now it says machine learning predict. It calls the model that we just trained. So based on the historical data, we trained the model. And now we will say, and to get the input data, just look at the predict table that we created. And that predict table has new users from the past week. And based on that, those initial interactions in the first week of them being a guest to our website or visitor to our website, we can start predicting who is likely to convert. So overall, we made predictions for 3,000 users. And then you can see it predicted if they'll convert or not, so true or false, label probability, and then importantly, we also have the user pseudo ID. So we have that identifier of a user. So now we can use that data to say, let's create an audience of users that will predict. So we could say here where predicted label is true, and give me the user pseudo ID. And then we got a list of 800 users out of all those first-time visitors that are very likely to convert. So all these have the first-party cookie that we can share, or that MiaProba can now read from our BigQuery table. And then this can be utilized in Adobe Target to maybe update the website, change the website a little differently, personalize them for someone who's more likely to convert and someone who may not be interested in our newsletter at all. So instead of like Panera showing that sell it for Brian, we could say, hey, this is where you sign up for our newsletter. And in the back end, we're thinking based on all your interactions and how you got to the website and where you're from, we think you would be very interested. So BigQuery ML is a very powerful way to use SQL and to use the data that we've collected in BigQuery. I showed you here an example of newsletter sign up model. What we could also do is we can do this on an individual level. So instead of bringing in a table of the users that visited our website from the past week, we can make up a user, or if you have specific set of users somewhere offline, you can start pinging your model with those. So here we say someone from Europe on Windows using Edge browser, using the came to our website through social, and the first landing page was webinars with 10 blog views. They're 0.64 predicted probability that they would translate into a newsletter subscriber. And predicted label at the end is true because I think our threshold is probably right at halfway. So if someone is 0.64, we're saying they will convert. Just as an example, we can change this a little bit. Or we can say America's here, and then instead of Edge, let's say Firefox, and you'll see that 0.64 now dropped to 0.57. So someone with these settings is less likely to convert. So again, we trained a model, we interacted with it, we made predictions just using SQL within BigQuery. BigQuery fully managed to take care of all the storage processing in the backend. In our case, we used Google Analytics data to do so. And now these audiences that we created can be immediately used by something like Adobe Target. You can also activate in different other platforms using these audiences. I have another interesting example as well. And I'll just show you that one pretty quickly. So k-means clustering of all the users that you have, you can cluster them, you can put them into different groups. You can have a machine do that for you with machine learning, BigQML here using k-means. And then we got, for example, 5 different groups of users based on their interactions in June. And then we can start putting our new users in those groups as well. So we examined about 11,000, 12,000 users here, and then it put them into 5 different groups based on their interactions with our website. Just another cool example of what BigQML can do. So I got a minute or two left here. This is something that could be its own collection of webinars, not just a single webinar. But in terms of activation, like I mentioned, Mia Prova is really handy here because it can read from BigQuery and then take advantage of that and use it in Adobe Target. When we were talking about activation, especially with the Google Analytics data that I was showing here, you can send this data back to GA4 by data import, or you can use it in Google Marketing Platform and within Google Ads, for example, finding that join with something like a Google Click ID or customer match. You can send data back to your own CDP. You can also access the data directly from your servers, from your website, or from your applications. There's a few other features that BigQuery has. Like I said, it went from data warehouse to this unified data platform. So AI-assisted query writing is something that could be a lot of fun, for example. So if I go back into that initial example that I have, we've written quite a few queries here. So that natality, I can explore with something called data canvas. And I can say for this table, I would like to write a query. And for this, I want Gemini or AI to write a query for me because I may not know how to write one. So I would like it to ask the data this. So let's say I would like to know weight in, let's do kilograms, at birth by gender. And then what Gemini is doing, what the AI model is doing in the background, it knows the schema of the table, of the natality table. It will then look at my question or my prompt here. And then because I mentioned kilograms, it's translating pounds into kilograms, which is pretty amazing by multiplying it by 0.45. And then it also is saying here, natality is male. So it's taking that is male option and group the results by gender. So instead of looking at each birth, I'll also tell it, can you group this? So we're seeing them as a totals, not per individual. And now it even did a little case statement here. So if it's male, it's male. Otherwise, it will say female, and it'll group by that first. So we can run this, and you'll see we went from our initial table, give it a little AI prompt, just as a fun thing here. And then you can see the average female at birth is 3.256 kilograms versus male, it's 3.374. There's a lot of fun things you can do in BigQuery. So you can start visualizing these results as well. You could start having it interpreted. So if I just click on the chart here from the one we drew earlier, where we said average weight pounds per year, you can see it was increasing and now it's slowly decreasing again. So a lot of fun things. It's AI assisted. If anyone's using Apache Spark, you can now run Apache Spark within BigQuery itself. It has Python notebooks in the back with their own library that looks a lot like data frames would, but it's called big frames. And then all the heavy processing happens within the BigQuery in that fully managed space. Data canvas is something I was just showing you where you can move through this very nice visual going from table to request to results and then keep working on that. You can have external connections to your own SQL. It has a data transfer service. So if you want to bring in data from other platforms, it's very possible that that connection already exists and you just have to turn it on. There are also data governance options with Dataplex. So a truly big and very featureful data warehouse that you can use with something like Mia Pro, as you saw with the examples, and then use it to take advantage of those audiences in Adobe Target. Yeah, Sandra, I think this is all. We got a few minutes left.
Yeah.
For Q&A.
Oh my goodness, every time you and Brian present something, I think of new ways that this can be used, and be used honestly pretty quickly by people who are not necessarily incredibly technically savvy. And that is I've been in the analytics space since 2008. That's such a huge change, and it's come on so quickly. I'm excited about that. I'd love to open it up for any questions that people might have. I don't have any outstanding questions right now, so we'll give it just a second. Okay, what I think you've done is given them so much to think about that they don't have the ability to ask questions right now, and that is perfectly fine. Today's webinar is about unlocking the power of BigQuery for Adobe Target Augmented.
Are you driving way less than you used to? Do you have a clean driving record? Are you over 25? Do you not have a DUI? Then you're likely paying too much for car insurance, and you can drop it.
All right, thanks everyone for joining. We're gonna go ahead and kick off. So welcome to our webinar on Google Tag Manager server side, as well as some Google Analytics 4 components. Next slide, Kayla. So first, just for everyone, a little bit about AdSwerve. We are one of Google's leading Google Marketing Analytics and Cloud partners. We've been working with the Google Marketing Platform from the very beginning with all the various Google products. So anyone that's looking for any help or for any additional resources on this, just let us know. First, we wanted to start off with just a quick introduction of our 3 presenters for today. So first, we have myself. I've been with AdSwerve, I think, for about 7 to 8 years, deeply experienced in all areas. Today, I'll be leading the moderation component as well as the Q&A at the end. I'm really excited to have both Kayla and Matt, who will be presenting all of our components on server-side GTM. I'll do our intro for both of them. So Kayla is a senior digital analyst. And to introduce her, I asked her for a fun fact. So Kayla, when she's not doing Google Analytics related work, you can find her on various aerial apparatus. And she also performs juggling. And I did ask, and she is able to actually do both at the same time. So quite a skill. And then we have Matt. Matt is one of our solution engineers. and he's been working with server-side GTM along with Kayla from the very beginning. And Matt's fun piece of information is he has a corgi. He has not yet had his corgi in any corgi races, so I'm encouraging him to get into that sport. And he can also beatbox, so maybe we'll get a sneak peek of that at the end as well. So with that, we're going to go ahead and get started. For anyone that has questions as we go through, the best place to enter those will be in the Q&A portion. We're going to handle probably the vast majority of the questions at the end of the webinar. We should have plenty of time to go through that. In addition, in our outro, we'll also share a variety of resources that we plan on sending all the attendees, different resources to help you get started, kind of take things to a deeper level, and kind of learn more about some of the various topics that we're going to explore. So with that, Matt, why don't you go ahead and kick us off?
Hi. Yeah, so before I dive into server-side GTM, we can discuss just a brief overview of the traditional client-side GTM. Next slide, please. So overall, Google Tag Manager is a tool that allows you to just manage and deploy tags, which is snippets of code or like tracking pixels on your website without having to modify your site code. It's enabled for analytics team members or marketers to not be able to have to rely on developers to add in certain codes to work for marketing tech or analytics tech and ad tech. So it's an abstraction, and it helps governance with different sectors of your orgs, and also just speed everything up as well. Next slide, please. So here's the traditional client-side GTM web container. Here you have the website, adserver.com, and then the GTM web container, and then inside the container you have your Google Analytics 4 web tag, and then whenever that's fired, say page view, it's sending out a request, an HTTP request to the Google Analytics servers that are owned by Google. In the request URL, you can see it's www.google-analytics.com/g/collect, and then rest of the query parameters. That's very important to just note as going on in this conversation. But go ahead, next slide. So what server-side is server-side GTM. It's essentially the same thing, just bringing that abstraction of being able to add logic for your component to the server instead of just the website. So with that, you're basically able to do the same thing, just adding in that simple logic to handle that data stream, and then passing it along to your server endpoint, whether Google Analytics or Google Ads or Facebook or whatever. But it's really the most important thing is it's almost the same exact thing, the same aspects as a web container GTM. It has tags, triggers, variables, and then there's a new entity called a client, which we'll talk about a little bit further later. But next slide, please. Thank you. So this is how a site would be for a GTM web container sending hits to your GTM server container to a specific meta endpoint like Google Analytics. So here, it's very similar on the website, adserver.com, and then we have a GTM web container on the far left, and then a Google Analytics 4 web tag. So you send off a HTTP request to your server container, but notice that the request URL is a little bit different. It's the endpoint. It's different because you're sending a request to your server endpoint that's owned by your org, and that infrastructure is Google's infrastructure, but you own that project, GCP project, and you own that code. And in that middle is the server container. Now the server container is just handling these requests, augmenting it, cleaning it, whatever it may be, and creating that data layer, that data object, the data model, and then passing it and running the virtual container to the server tags. For this specific instance, it's a Google Analytics 4 tag in the server, and it's then sending off that request to your Google Analytics servers or to the Google Analytics servers. So it's essentially just a proxy in the middle, handling those requests, fixing, amending, or augmenting, cleaning, and then passing it on to Google Analytics. Next slide, please. So as I mentioned before, there's a new entity called a client. Now, in that diagram before, really all it is it's just listening in the front of your server container, listening for HTTP requests with a certain URL path and certain request URL, and grabbing and claiming those requests. Once it claims those requests, it basically can build that data layer object or data object, and then passing it to any type of vector tag or Google Analytics tag or Google Ads or floodlight tags, and then waiting for those responses and then sending back a response. You can kind of think of it as GTM server side as essentially an airport, and you can kind of think of a client as a GSA. Go ahead, next slide, please. So think about basically your GTM server container is an airport, right? And you're at home. Say your website is adserver.com, imagine that you're departing adserver.com. You want to eventually arrive to googleanalytics.com. A GA4 hit would be having a URL endpoint would be g/collect. A universal analytics would be /collect. If you think about the analogy that I have here, it's essentially these requests are your boarding pass, specifically that endpoint, the URL endpoint, g/collect. Now, g/collect is specifically for Google Analytics 4, and /collect is specifically for Universal Analytics. So if you're sending a request or you're going to the airport, the TSA is basically going to check your boarding pass, which is this, that HTTP request incoming, and it looks at that endpoint, g/collect, and it sees that you are going to Google Analytics 4, or it's Google Analytics 4 tag, you want to go to Google Analytics, so it directs you to this correct gate, which is a Google Analytics 4 tag, and that sends you off to GoogleAnalytics.com. Same thing with Universal Analytics. If you have a boarding pass for Universal Analytics, if you're departing adserver.com, you want to go to GoogleAnalytics.com, you have to figure out which gate you want to go to. Server container will basically direct you in the right direction, and /collect for UA is essentially Universal Analytics tag. So go ahead, next slide. So here, to drive this analogy, here is a Google Analytics 4, as I mentioned before, the diagram from web container to server container, and that g/collect is very important because these clients are looking at that URL mapping, and specifically for Google Analytics 4, it's looking for g/collect, finds that URL endpoint, claims it, constructs the data model, and then runs the container and passes that data, to the Google Analytics 4 servers, and then it's triggered based off of any type of event trigger that you want, or even other triggers, and then it's fired and sent off to Google Analytics servers. Go ahead, next slide.
I am terribly unorganized, and it was starting to affect my online business. Time blocking my schedule worked for a little while, but it took almost as long as the tasks in the schedule.
And that is my speech.
All right, now that we have a good sense for the overview of what server-side tag manager is, we'll dive into a couple of the considerations that you'll have to take into account when deciding whether or not you want to use server-side tagging, and then we'll do a quick demo so you kind of have a sense for what's coming, which should solidify some of the concepts that Matt just talked about. So first, we'll talk a little bit about the benefits. First, privacy and data security is a big benefit of server-side tagging. Using a server-side proxy for your data enables you to protect your users' privacy, and in doing so, you gain some of the privileges with browsers that have strict cookie policies, which will soon to be all of them. There are a couple of things of note. Your IT team can put a policy in place that limits the access to certain APIs at a server level, so they really have control over what this technology can do on your website. You can update the data from an incoming request and either exclude it from an outgoing request or modify it, like Matt mentioned. So you really have control over what actually makes it to vendors. An example of what that could look like is you may have a user agent string or an IP address coming in from an incoming request. Maybe you don't want that data in GA4, so you can exclude that data from the outgoing request to Google Analytics servers before it gets there. So you really have full control over kind of what user data makes it into what platforms. And then probably what most of y'all are interested in is that if you have your server mapped to a custom subdomain of your own website, you can use a server managed HTTP only cookie for the tags for your tags that will persist past the 7-day limit now placed on JavaScript cookies by the latest ITP update, which is a really big benefit of server-side tagging and probably a lot of why there's a lot of interest in this technology. The second point here is efficiency in data collection, and this really speaks to kind of Google has announced that core web vitals, so page performance, page speed, general user experience on your website are kind of now considered ranking factors for organic search, and also user experience is an important aspect of any website. You want to make sure that it's fast so that your users will continue to engage in it. And really, this is a key benefit of server-side tagging as well. You can consolidate those incoming HTTP requests so that the JavaScript load on your website itself is decreased, and it puts some of that burden on the server container itself. We'll talk a little bit more about that. But basically, that just means that you can, for example, the GA4 client can cause tags to fire to Google Analytics 4 and Facebook and Google Ads, for example. So it kind of reduces the amount of requests that happen on the browser itself. And then the third aspect here is data ownership. So because you're routing the data through your own servers, so your own cloud infrastructure, you have full ownership and control over that data. Next, we'll talk a little bit about the challenges. There might be some reasons why you might want to consider not using server-side tagging or what you might want to prepare before you move to server-side tagging. First and foremost, that is consideration of resources. Because you're using your own cloud infrastructure to route requests rather than relying on the user's browser itself, there are costs associated with that utilization, the outgoing requests from your cloud infrastructure, that's called network egress, and potential logging. So the sort of utilization and storage of that data will incur costs. There's also a cost associated with the management of this cloud infrastructure. Server-side tagging is not a set it and forget it implementation. Continually monitoring network egress, logs, consolidating your data streams so you're not pinging your server with redundant requests. And monitoring your use of your instances to ensure that your server can handle the traffic being sent to it are all critical pieces to a server-side setup. And so knowing kind of what partner you'll work with or having internal resources that will be managing that infrastructure will be really important to consider. Another consideration for resources is what's called client-side tagging. I know client has a lot of meanings here, but by that we mean the web GTM container, that normal kind of what we've been using for tracking so far, that web GTM container, that setup is still going to be relevant. You can send HTTP requests to your server container from any online connected device, but what the most common use case we expect will be is sending those requests from your web container, relying on a solid data layer setup the way that you're sort of probably already used to, and sending that data to your server container. That will be the typical flow. And so resources may be required to get your client-side setup on the website itself up and running and clean as needed for the server setup. Another consideration here is vendor adoption. So not all vendors have adopted compatibility with a server-side endpoint. So many of your pixels might still need to be in your web GTM container. It's expected that a lot of them will move in the direction of being able to first send those hits to server-side and then onto their specific server endpoints. But at the moment, it's not like 100% fully adopted. Google has created some easy ways to work with this, which you'll see in the demo. And then transparency. So it will be important to be kind of transparent with your users that about how you're collecting their data and that you're respecting their consent, even if they can't see those network requests. So we've talked a lot about data consolidation and sending hits from that are collected from one partner to other partners, and in this process you'll just have to make sure that you're still respecting consent and have the legal basis for collecting that data within that particular platform. Next, we'll go into the demo. I will use the setup of a GA4 tag and a Google Ads conversion pixel for this demo. But first, I'll just kind of go over a little bit of what that process looks like, and then I'll jump into the platform. So before you do this, you have to create a GCP or Google Cloud Platform project, which is where you'll deploy your server. A quick note about this is you don't have to use GCP. You can configure other cloud platforms like AWS to serve the same purpose. We're using GCP in this example because it's pretty compatible and it's easy for a demo. Then you create the server-side container. GTM makes this super easy. And this will be the place where you build the client's tags, triggers, and variables like you have probably already done in a web container setup. Then we'll configure your a web tag to send data to the server. Excuse me. We'll create a client that will accept that request, and then we'll create a tag and trigger that will then send that on to Google Analytics. So kind of the full process in a couple tags here. All right, so first, I'm going to create a new container just to kind of give you a sense for what this looks like and how easy this is. So I'll just call it testing for now. So when you create a new container in GTM, you just select server. So they make it pretty simple, and then you click create. From here, I'm going to provision a tagging server. And this is, in this example, I'm going to automatically provision a tagging server, which will be on an app spot domain. And this is good for testing purposes. Matt will talk a little bit about later about moving to production. And I'll show you just where you get to this outside of this pop-up. So where you normally find the container code, that's where you'll find where to automatically provision your container. In order to do this, you have to have a billing account for GCP. So you have to set that up prior with credit card information. That's a requirement for this since you can incur costs. I'm going to exit out of this because I created another example container here. So once you have a GCP account, you have your billing account sorted, you've created a server container, then you're going to configure the tags in your web container. So I'm using a juggling prop website as our example website here, but I have a testing web container set up here where we've got a few GA4 tags, a form submission, page view tags, etc. That we're going to use in this example. And in order to configure that all of those hits to go to the server container, Google Analytics 4 has made this super easy. It's literally just a check mark. The server container URL is actually what we find after we automatically provision the tagging server. So I'm going to pull this default URL and make that the place where all of my GA4 hits get sent. So I'm going to save this. And now I need to configure a client. So I need something to accept those incoming HTTP requests from GA4. And luckily in a server-side container, the GA4 client and the Universal Analytics client are there automatically for you. We're just going to create a few or just change a few of these configurations. So priority means if there's more than one client in the container, then the one with the highest priority, the highest number, is the one that wins, and that's what will accept the request. In this case, we can leave it at 0 because there's only one client that's going to accept a GA4 URL, which is what Matt described earlier, that boarding pass. So we can leave that at 0. This default GA4 paths is just saying if it's g/collect, they have the GA4 boarding pass, we will go ahead and accept that request with this GA4 client. We can ignore the second setting for now. You can kind of hover over that question mark to see what it does, but we don't need it for the specific example. And then you have more settings. So this is where we talked earlier about being able to use a server managed cookie versus a JavaScript managed cookie. Here's where I would set that up. Because this is a testing app spot domain and not a custom subdomain of my website, I can't use a server managed cookie here. And so I would change this to JavaScript managed, which just means that it's the normal GA cookie that you're used to, rather than a first party HTTP only cookie. It's the previous JavaScript set GA cookie. And so I'm going to save these settings. Now that I've created a client, I need to create something is accepting the incoming request. Now I need to have something evaluate the parsed incoming request and then send that data onto Google Analytics 4. So I'm going to create a tag to do that. Name it something generic for this example. Just like the web interface, I can create a tag. The configuration is super easy, especially for this example, because I'm inheriting what gets sent to Google Analytics 4 from the incoming request to our server. So I can override the measurement ID, or I can redact the user IP address, or I can decide to send a specific event and not others. I can change event parameters, add, exclude, etc. But for this example, I literally just want to say everything that comes into my server that has this boarding pass URL, send it on to GA4. And so we don't need to configure any of this, but where this becomes useful, say you have personally identifiable information being collected by the GA4 client, here's where you might exclude it. So no configuration is actually needed for this example. Now I add a trigger, and this is quite simple as well. I'm going to call it client GA4. Oops. And I'm calling it that because I set it on a custom trigger. So you select custom, that's set to fire on the client of GA4. So client name equals GA4. And what this does is it says every time the client parses, or the GA4 client accepts an incoming request, parses out all the data into what's called an event data object, this trigger will say, now that event data object has been parsed, all of the data within it will then be sent to Google Analytics 4 in the format that it expects. And so pretty easy, I've set up my GA4 tag. And I almost clicked exit. I'm going to save it instead. I want to show a quick example of what it's like to set up a Google Ads conversion tag as well, because Matt's going to speak to that in a moment, just kind of how that all works, just so you have kind of a reference of what that looks like. So this is pretty similar to what you see in a web container setup. You have to create a conversion linker tag just like you do in your web container. You add your conversion ID, which I'm just going to give a fake example of. You get similar settings as you would in a web container setup. I'm going to just set up this conversion linker tag to fire on all pages. Oops, sorry about that. On all pages. And then, actually, sorry, I need to set it to trigger on forms because this is not a remarketing tag, this is a conversion tag. So how I would set it up to trigger on just forms is I would use the event data object that GA4 is going to parse. And I'll show you how that's done. So again, I'm going to use a custom event. And this custom event is from what the GA4 client is parsing, not a data layer event. And I'm going to set it to fire when the event name equals form, since I know that's how GA4 is going to parse that request. So if we look at the overview here, we set up a client, we set up two tags, we set up a variable and a couple of triggers to make sure that those fire. I would put, because my web container, this one, is not live yet, I'm going to go ahead and put it in preview mode so we can kind of see this in action. I put my server-side container in preview mode and nothing's fired yet. I'm going to go ahead and fire a page view tag. And we'll see here, this is the event data object that was parsed by the GA4 client. If you go to the request tab, you can see that the GA4 client claimed the request. You can see what the incoming request looked like. And then you can see the outgoing request that was done by the GA4 tag. And this is the URL string that we know and love that gets sent to Google Analytics servers that we usually see in the network tab, but is now being sent by our own server. If I do a quick form submission, which I configured the Google Ads tag to fire on, we see that the GA4 client claimed the request and the GA4 tag sending data to GA4 and the Google Ads form conversion tag both fired. So we're going to jump back to our our presentation here, and now it's going to talk about moving to production.
Yeah, thanks. Great demo. Go ahead, next slide, please. So Gil mentioned before.
So you're already using ChatGPT, and while that's awesome, there is one little problem. You're not.
Before about the subdomain, that's a very important aspect of server-side, because overall, the main point of server-side is leveraging first-party data without mapping a custom subdomain to your server. You're not going to be able to have server first-party data. So in this example, Caleb spun up App Engine. That's the default way to have a VPN server-side in GCP, but there are other methods. But specifically for this, if you have the default URL, you need to map the custom subdomain to the App Engine server using A or quad A records instead of CNAME. That would probably be the first step right off the bat after spinning it up, is to have that mapping, because it allows you to enable first-party data can be sent to your server, but also just in general, there's a new aspect of server-side, which is the JavaScript or server-side managed cookie, which sets a cookie in the header response and then has a HTTP only attribute, not allowing JavaScript to affect anything for that cookie. And then the next step would be to just evaluate your server and just any type of JavaScript managed cookie. So that's another thing, is talking about the cookies currently without server-side using the GA cookie, that's JavaScript. That's a cookie that's managed in client-side in JavaScript. If you had migrated to the server managed cookie, the default name is FPID. It's going to change the flow of how you use cookies. So if you're using analytics for a different vendor and passing in the GA client ID cookie value, if you're using that JavaScript or server-side managed setting inside your server, it's actually not going to account for that GA cookie client ID. It's actually going to just use a server managed cookie that's actually visible inside the browser, but it's only available to be passed via the server. So you have to make sure that your team, your marketing team, or your analytics team is aware of what these cookies are, what they do, and how they're created, and how they're going to be used downstream. Another aspect that you should evaluate before moving to production is evaluating the cloud costs. So there's you have to, even though, so when you're using GTM web container, you're not accounting for any of that cost. It's free. Everything's being ran on the user's browser, user's laptop or desktop. You're moving this GTM container essentially to the server container, and you're managing those costs. So all that CPU utilization, all that storage and memory, it's all being handled in the server container. Now, App Engine, I think the default is recommended for Google is minimum 3 instances and max of 6 instances. That'll account for a lot of a high number of requests, but roughly it's like around 120 per month, depending on the amount of requests and the amount of computation that you're doing in the server container. But you need to have awareness about your organization on how much this would cost. There's ways to evaluate it using GCP calculator, but the main components really are CPU utilization, memory, and the outgoing requests from your server container. So when you do roll out to production, as I mentioned before, using App Engine, when you first spin it up using automatic deployment, or even if you use a manual deployment, you want to be in that standard environment, and that's specifically for server, specifically for testing. You wouldn't want to move that or use that standard environment for production. What you're basically doing to move to production for App Engine, you're just updating, you're running a little script given by Google, and it moves it to a flexible environment, and that's where you're provisioning more instances, handle more requests, and being able to auto scale and handle a good amount of requests. After you do roll out, you'd want to monitor. So logging is enabled by default, but it is costly after a certain amount of after it hits that certain quota. So that's things to consider. But there's also other attributes within GCP that allow for monitoring, making sure that you're not seeing 503 requests or 500 requests, so that would cause an alarm, and you probably want to know like what's going on, and you can investigate within your GTM server container. Go ahead, next slide, please. So I dove a little bit into the cost pricing, but I can go a little bit further. So as I mentioned before, you're moving that enablement into the server, and you're managing that server. If you're using GCP, then all of that infrastructure is handled by Google. You're managing and you're maintaining that project in GCP. So each instance, if you're doing on App Engine, is roughly around 40 a month. So recommended by Google is minimum 3 instances and max of 6. Roughly is 120. But again, it depends on your location of your users and how many requests you are getting per month. And a good way to calculate it is their hit volume in GA. You have to account for not only your Google Analytics stack, but also any type of request from the vendor going outward. Because if you do some type of consolidated method, pushing all that data into your server container, there's going to be requests sent out from each vendor tag, each GA tag, and so forth. So you have to account for that hit volume. There's other dependencies and factors for the cost, such as the number of tags and complexity of the tags and regions and logging and monitoring. So because as I mentioned before, that all that utilization of the computation CPU is being moved from the user and their browser to the server. So if you have a complicated regex logic inside your server container, it can be a little bit costly. So it's pretty easy to create tags and build out logic in the server container, but you still need to have a relationship with everyone in your org when managing a server container, just to understand different computation possibilities or certain aspects of managing a server container. Go ahead, next slide. So I want to talk a little bit about the Google Ads tag and server side. So right off the bat, it's still using third-party cookies as of now, because Chrome hasn't disabled third-party cookies yet. I'm assuming when that does happen, they'll remove this third-party cookie enablement. But it is creating a first-party cookie called FPGClaw, and that's essentially the cookie inside on the client side. One of the main benefits of using this is to reduce client-side bloat, so you're not needing to load conversion_async JavaScript asset, and you're able to consolidate all your data. Instead of having separate HTTP requests, you can have it one consolidated data stream under a GA4 hit and fanning out to a GA4 tag and a Google Ads, and also the conversion linker tag, reducing the number of requests in a sense. Again, Kayla mentioned that it's the same configuration. You're adding the conversion action, conversion label. It's very similar, very easy to set up. Go ahead, next slide, please. So here would be a consolidated data stream. As I mentioned before, it's one GA4 tag sending off to Google Analytics for clients, and then there it fans out. It's very important to have that conversion linker tag set on all pages. We're also not going to be able to set that first-party cookie, FPGClaw. So the way that this works, and it's kind of a little complicated, so it's okay if you understand it, but pretty much it's that request being sent from the web container, from the GA4 web tag. It's being sent to your server container, and there's a couple requests that are being sent out. One is GA4 tag, the other is Google Ads conversion tag to calculate conversion, and then that conversion linker tag is being sent to set that first-party cookie. There's a response back to the GTM web container browser side, and there's a mechanism that basically does client-side ping and sends out a request for Google Ads to enable those third-party cookies. So again, you're still utilizing third-party cookies. It's not totally first-party. So overall, sorry, your server container cannot handle any third-party cookies. It's only first-party cookies. So this is why you have that enablement as of now. But I'm assuming when Chrome does remove third-party cookies, this whole client-side ping was going to be gone, and it'll have a little bit more leveraging of modeling in the backend for not having this third-party cookie being sent out. But next slide, please. So it's very important to know when you're setting this up, you have to consider consent. And if you have some type of consolidated effort, it's important to be transparent with users. So here's an unconsolidated data stream where you're having specifically for Google Analytics for data up top, and then below is specifically for any type of conversions for Google Ads. It's still, you're not really consolidated to multiple streams, but at least it's a lot easier to handle the processing and consent of your tag and your data stream. Google's done a really good job of helping with this, specifically with consent mode. There's features called ads_storage and analytics storage that's enabled within GTM web container to help in ease with this process of managing the consents. And next slide, please. So yeah, I wanted to talk a little bit about the consent and privacy settings. Next slide. So whenever I do talk to clients and stakeholders about using GTM server side, I always ask about how they're handling consent. And if they're not, I advise them to just think about it and talk to the legal team about it and how they would want to manage that. But it's important to have some type of relationship with the users and transparent relationship with the users. So server side is going to be leveraging heavily on first-party data. And with that, there's also ways to send out this data and fan it out with no transparency. And that's not the best way to handle this, because this movement for measurement is we're fully leveraging first-party data and then modeling for data that's not able to be identified. So you want to have proper consent, and Google's provided a great mechanism called consent mode, as I mentioned before. And yeah, it's important to have awareness throughout your organization, because there's many different orgs. You got your marketing, your analytics, and your engineering orgs, and many more. So it's important to make sure they all understand how it's working, how consent's handled, because not everything is available fully for consent mode. It's not. There's only a few custom templates right now for consent mode. So if you're using something like OneTrusted, you probably have to do a little customization for custom template for that, which is not too hard, but it's important to do it properly and to be transparent with your users. Yeah, let's go to the next slide. Oh, Charles, you're on mute.
Yeah. Well, thanks everyone. We're going to wrap up. So what I wanted to do is first kind of summarize a few key learnings, as well as cover some of the additional resources and recommendations we have. So hopefully, as you saw through this webinar, some of the stuff probably made a little bit of sense, and some of it made no sense at all. So to summarize a few things, I have kind of three key things I think to take away from this. First, a lot of what we covered actually had a lot of integrations or connections to GA4. And the reason this new version of Google Analytics was talked about a lot in our webinar today is actually because many of the integrations that have been built right now depend on it. So if you're getting started with wanting to send data to Facebook server side, or even the Google Ads connectors that Matt said, a lot of the out-of-the-box functionality actually uses GA4 as kind of the central pipeline. So this is where this new version of Google Analytics is kind of becoming more important. And just a little bit larger is actually Google's kind of move to GTag as a central repository for almost everything they're doing. So if you're getting started, just note that GA4 is kind of the requirement just because of the ease of out-of-the-box functionality that's being built in. Secondly, another thing you might have picked up on, and I think Kayla did a great job of connecting this, is that client-side tracking is still very much a requirement, even if you want to do server-side tracking today. And the reason client-side tracking is somewhat of a requirement is if you have an expectation for your marketing stack to have parity with what you're doing today, client-side tracking just is very much an integral part. And the reason that is because a lot of the things that we do with our marketing tags is about building audiences that we then can reach later through remarketing or lookalike audiences and all these other things. And one of the requirements is you need some sort of ID for a user to find them later. And most of the ID space that we use today for digital marketing is either built off of first-party cookies or even more so third-party cookies. And even though third-party cookies are rapidly going away, a lot of our marketing integrations still use those today. And because of that, once you get into some of the libraries, like using the Google Ads tags as an example, they're still creating some of those cookies, even in those server-side instances. So the client-side tracking and the server-side relationship, there's still a bridge there even today. And lastly, I think the third takeaway is simply this stuff is complex. When we think of Google Tag Manager or a lot of Google solutions, you think of, I always think of ease of use as kind of a central component. And client-side Google Tag Manager is fairly easy to use, but it's still really complex, even with what we've had in the past, once you get into custom HTML tags and all sorts of the advanced integrations. And server-side takes that to a whole nother level. And Kayla, I think, summarized it best. Server-side GTM is simply not set and forget. It requires even more visibility and maintenance and updates and keeping track of cost and billing. So just know what you're getting into. It's not anywhere near as easy or simple as client-side. With that being said, with all those 3 points though, we really do believe that server-side tracking is going to be an integral component of your marketing stack in the future, because this is where a lot of our industry and solutions are headed. I think all of us are in a place where we desire more secure and more transparent ways of how we send and structure data, and being able to reduce the bloat of all these client-side tags, being able to send consented data in more secure ways so we don't have risks of data leaking is an obvious win. And those are really the key value props of what server-side opens us up with. So with that being said, we have a variety of resources that we want to send to you to hopefully help you get started if you want to. First of all, we'll follow up with the resources that are listed here. We have onboarding guides. We also have intros to GA4. Matt and Kayla have both wrote some amazing blog resources. In addition, in our industry, if you're not already following Simo has an amazing list of resources around server-side GTM, so you'll definitely want to follow his material as well. And then in addition, we will be emailing, again, all of these resources that we just listed, as well as the recording and the slides for this webinar. So again, not important that you retained even maybe 10% of what we're talking about, but as you're getting started later, these will all be great resources to kind of go through step by step to get started. So with that, we do have a few questions that we wanted to handle and go over. So the first question is either for Matt or Kayla. How long would you estimate it takes to actually implement server-side tracking? So let's say you wanted to do like Google Ads and enhanced e-commerce and Facebook. What is the sort of time commitment or length you would think it would take to do a project like that? So Matt, why don't you take that one?
Yeah, it actually varies. So if you have a very long list of Google Ads tags, and you need to ensure that first that consent management piece is in place. And if it's not, you need to start talking to your org and understanding how that's going to be developed with the server-side flow and Google Ads. You want to do a parallel test and run a test tags along with your current setup, and just evaluate for yourself to see if there's data loss. If not, we've done it for our setup for Google Ads and then Floodlights, and then for our internal setup, and we've seen that there's only like a little bit of variance, but it's important to have a good setup for parallel stream and then doing a cutoff when the time's right. So at least I'd say probably like 14 days just for true evaluation of seeing a parallel stream and evaluation and the cutoff. But you have to have a proper GA4 setup and also just understanding how you would consolidate, I guess, or if you want to consolidate.
Yeah, that's a great answer. Another thing that kind of comes to mind related to the question is one of the best places to potentially get started with server-side is if in the past you have been doing anything with a measurement protocol for Universal Analytics or even GA4. If you're not familiar with a measurement protocol was a way you could send data from anywhere to Google Analytics. So as an example, for a lot of our clients we worked with who had OTT apps, like if you built an Apple TV or Roku or a PlayStation, often you would kind of code your own libraries and send these HTTP requests through measurement protocol directly to Google Analytics. Or potentially maybe if you sent some CRM information or whatever, you'd send it directly from your server to GA. Now the challenge in the past was that data was sent directly to Google Analytics. So if you also wanted to send it to Facebook or your own cloud endpoint or anywhere else, you would have to go back into your app later and then build those integrations because there was no tag management component for server-side sense. Now, one real cool thing is you can easily go into a measurement protocol implementation today and simply change the endpoint and claim them in your server-side instance, and then from there build the clients to then send that information anywhere. So one of the easiest places to see value is anywhere you've used the measurement protocol in the past. Our good friend Josh, who's attending, asked the question. Kayla, do you have any idea when Google might release Floodlight libraries for server-side?
That's a good question. I actually don't know when they're releasing it. I know it's in the works. Matt, do you know what the timeline is?
There's no specific timeline, but I feel like it's coming very soon. We've been testing it for a long time, so it's very soon.
Google's been working on that, but no timelines have been released. Another fun question, Matt, if you have any opinions, what type of logging do you think is essential? And do you have any recommendations on any sort of logging that should be disabled? And this is a good question because one of the things Matt alluded to was, again, you need to kind of pay more attention to what you're doing with server-side GTM because there are best practices and ways to optimize cost. And logging is a big component of that. So Matt, do you have any thoughts on logging?
Yeah, it kind of depends also. So logging is expensive if it's over that free tier, but it's pretty essential. If you have 5 or 3 responses, you're gonna want to know why, and understanding possibly that there's too much data inside the headers of your request. So you have to talk to your team and evaluate what is important to capture and that mechanism, rather if you even incorporate some type of Slack mechanism. But I would filter if you're concerned about pricing, but want to be conscious. A good method is just to filter only for 500 plus, but you want to expect or 400 plus, but it kind of depends on how you want to capture data. Like there's also ways to measure latency and understanding, maybe you need to change the architecture of your setup, because if you have just one app engine server project in US Central and you have users from all over the world, it's probably not the best setup. And if your organization is really focused on web performance, then you need to evaluate and change the architecture, possibly even set that up before you just set up app engine or migration. So I hope that answered your question.
Yep. Thanks, Matt. Another question from Simon. How will ad blockers react to server-side tagging, and given it can now be used to circumvent ad blockers? So I'll take the first stab at this one. So I love getting this question because it really opens up some really important concepts, and Matt and Caleb both hit on these. Consent is a huge part of this, and more so just kind of taking a perspective of doing what's right and respecting users' choices. Now, with ad blockers, it's a pretty explicit signal from the user that they don't want to be tracked. So one of the things that Kayla, I heard she mentioned, is a lot of the server-side components are dependent on client-side. So if you're building a bridge from client-side where it's sending the server, it's actually likely or somewhat likely out of the box that some of that might be blocked in the first place, unless you've explicitly gone in and chosen to hook things up differently. And that's where, if you're choosing to do that, you should, as a best practice, be asking for consent. And if the user consents to being tracked and you're being very open about what you're doing with the data and giving them the right to opt out, both initially and later, then you're not running into that issue. And it's going to be consent driven, and you're going to, at the end of the day, feel really good about what you're doing. So as long as you put a consent flow in place where you're asking for that consent in the beginning, and then those flags are feeding to server side, whether consent is given or revoked and various subcategories of that, you're going to be in a very good place. So the best practice there is if you're doing any sort of customization and going your own way with building collection pipelines, just think of consent and actually have it at the beginning, and you'll be in a great place. But the best guiding light there is do what's right. Let's see, we had a question. Do either of you have any guesses of when server-side GTM will no longer be in beta? Because right now it actually has the beta label applied to it. Any guesses on that?
No questions. No guesses, but I'm assuming after the key products are pushed out, maybe. But there's, who knows?
Yeah, I think it's important to add that Google has a long history of keeping things in beta for a very long time. Even Gmail was in beta forever. And in Google Analytics, even the existing universal version, there's still things in beta in there that have been beta for 5-ish plus years. So I think what's important is betas are something Google generally considers as very stable. And once something's in beta, they tend to not release anything that will break it without lots of notice. Alphas are usually the ones that we put more scrutiny on and you want to be more careful about. But again, in general, just based off of the Google marketing platform of what's in beta, those have generally been fairly stable and things historically we can generally rely on. So personally, I've never been that concerned over the beta label myself. So with that, we're pretty much at time. So if you have any questions or you're looking for any help, you can definitely reach out to any of us. You can find us all on Twitter, just as our names, or LinkedIn.